Bet you didn't think you were going to hear my voice, did ya? Okay, so we're going to be learning a whole unit on systems of equations. The rest of this semester it's just going to be the solving part, and then the beginning of next semester it's going to be applications, and maybe you know what applications means. So first I want you to watch this video, and I'm going to interject.
Let's say I have the equation y is equal to x plus 3, and I want to graph all of the sets, all of the coordinates x comma y that satisfy this equation right there. And we've done this many times before. So we draw our axis, our axes. That's my y-axis. That's my y-axis. This is my x-axis. That's my x-axis. And this is already in mx plus b form, or slope-intercept form. The y-intercept here is y is equal to 3, and the slope here is 1. So this line is going to look like this. We intersect at 0, 3, 1, 2, 3, at 0, 3. And we have a slope of 1. So every one we go to the right, we go up 1. So the line will look something like that. It will look something like that. It's a good enough approximation. So the line will
You should really be counting out the slope here.
When I'm drawing a line, every point on this line is a solution to this equation, or it represents a pair of x and y that satisfy this equation. So maybe when you take, let's say you take x is equal to 5. When x is equal to 5, you go to the line and you're going to see, gee, when x is equal to 5 on that line, y is equal to 8 is a solution. It's going to sit on the line. So this represents the solution set to this equation, all of the coordinates that satisfy y is equal to x plus 3. Now let's say we have another equation. Let's say we have an equation, let's say y is equal to negative x plus 3, and we want to graph all of the x and y pairs that satisfy this equation. Well, we can do the same thing. This has a y-intercept also at 3 right there, but its slope is negative 1. So it's going to look something like this. It's going to look something like this. Every time you move to the right one, you're going to move down 1. Or if you move to the right a bunch, you're going to move down that same bunch. So that's what this equation will look like. Or this represents every point on this line represents a x and y pair that will satisfy this equation. Now what if I were to ask you, is there an x and y pair that satisfies both of these equations? Is there a point or a coordinate that satisfies both equations? Well, think about it. Everything that satisfies this first equation is on this green line right here. And everything that satisfies this purple equation is on the purple line right there. So what satisfies both? Well, if there's a point that's on both lines, or essentially a point of intersection of the lines. So in this situation, this point is on both lines, and that's actually the y-intercept, the point.
So the key here is when we're graphing two lines or a system of equations, we're looking for the point of intersection.
0, 3 is on both of these lines, so that coordinate pair, or that xy pair, must satisfy both equations. You can try it out. When x is 0 here, 0 plus 3 is equal to 3. When x is 0 here, 0 plus 3 is equal to 3. It satisfies both of these equations. So what we just did in a graphical way is solve a system of equations. A system of equations. Let me write that down. System of equations. And all that means is we have several equations. Each of them constrain our x's and y's. So in this case, the first one is y is equal to x plus 3. And then the second one is y is equal to negative x plus 3. This constrained it to a line in the xy plane. This constrained our solution set to another line in the xy plane. And if we want to know the x's and y's that satisfy both of these, it's going to be the intersection of those lines. So one way to solve these systems of equations is to graph both lines, both equations, and then look at their intersection, and that will be the solution to both of these equations. In the next few videos, we're going to see other ways to solve it that are maybe more mathematical and less graphical. But I really want you to understand the graphical nature of solving systems of equations. Let's do another one. Let's say we have 6. That's one of our equations. And let's say the other equation is y is equal to negative x plus 6. And just like the last video, let's graph both of these.
You're going to see the importance of having graph paper for the homework right now.
Let's graph both of these. There you go. Let me draw some. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I should have just copied and pasted some graph paper here, but I think this will do the job. So let's graph this purple equation here. Y-intercept is negative 6. So we have, let me do slash 1, 2, 3, 4, 5, 6. So that's y is equal to negative 6. And then the slope is 3. So every time you move 1, you go up 3. You move to the right 1. Your run is 1. Your rise is 1, 2, 3.
Okay, so I don't actually connect the dots when I'm doing these. So I'll draw the dots of the first equation in one color, and I'll draw the dots of the second equation in another color, and then I will connect the dots once I know where they're going to cross. So let's just watch what he does, kind of leading by not a great example.
That's 3, right? 1, 2, 3. So the equation, the line will look like this, and it looks like I intersect at the point 2, 0, which is right. 3 times 2 is 6, minus 6 is 0. So our line will look something like that right there. That's that line there. What about this line? Our y-intercept is plus 6. 1, 2, 3, 4, 5, 6. And our slope is negative 1. Negative 1. So every time we go 1 to the right, we go down 1. So you go 1 to the right, you go down 1. So you go 1 to the right, you go down 1. And so this will intersect. This will intersect at, well, when y is equal to 0, x is equal to 6. 1, 2, 3, 4, 5, 6. So right over there. So this line will look like that, the graph.
So here's where he's showing you basically what you should not do. So it looks, let me give it a little another second. There we go. So it looks like they're crossing off to the side of that point that he has right there. So first thing is, this would be much neater on graph paper. Okay, so if you have graph paper, you're going to want to use graph paper. Second, keep counting out your dots. So I don't connect these dots because when I'm drawing this line, I don't know where the other line is going to be, so I don't want to connect the dots yet. So I will literally draw these. I usually only draw 2 dots, right? And then I'll draw another dot over here. Then I'll start without connecting those purple dots. I'll start graphing this, so I'll draw my dot there, I'll draw my dot there. At this point I can tell they're going to cross somewhere over here, so I'm not going to bother with a point over here. Sorry about that. And then I'm going to say, okay, I'm going to keep counting, down 1, down 1, down 1, down 1. And then with this one, I'm going to go up 3 and over 1 again, and that's where I'm going to see that they actually cross right there on that exact point. Okay, so if you're like him and you just like sketch it and then sketch it, then you're going to be like, oh, that looks like it's at about, I don't know, what is it, 3.5, 2.5, something like that, okay? So I'm not going to finish playing this video. He's going to show you how he confirms the exact point. But what my point is, draw your y-intercept, go up 3 over 1, leave the dots, don't connect them. Draw your y-intercept, go down 1 over 1, and then at this point you can realize you're probably going to need a couple more dots. Who knows if you're going to draw as many as you need right off the bat. Maybe you're going to draw an extra dot. Maybe you're going to stop here. Then you realize you're going to need more dots here, so you're going to go up 3 over 1, and then you're going to go up 3 over 1, and you're going to see that they cross right at that point right there. So the solution to this system is the point of intersection, which in this case is 3, 3. So if I scroll to, where does he write it? Right here. You can see he writes 3, 3. Okay? And I'm not going to show the rest of that. All right, so here's what you're going to be doing on some of your homework.
Just in case we encounter any more trolls who want us to figure out what types of money they have in their pockets, we have devised an exercise for you to practice with. And this is to solve systems of equations visually. So they say right over here, graph this system of equations and solve. And they give us two equations. This first one in blue, y is equal to 7/5 x minus 5. And then this one in green, y is equal to 3/5 x minus 1. So let's graph each of these. And we'll do it in the corresponding.
Actually, you know what? I'm going to do this. Let me skip his video and see if this works. Okay, so this is what you're going to be doing on your homework. So you're going to start with, here's your system, okay? The b is 5, so I'm just going to, this guy's already at 5, so I'm just going to do that. And then the m, the slope is -7, so I need to go down 7 and over 1, so that's my first line. My second line, the b is -7. I'll put that at -7, and the slope is -1. Oh my gosh, seriously? So I need to go down 1 and over 1 from there, okay? And if I were doing this on graph paper, I'd want to make more points so that I could see exactly where they're going to cross, because my lines aren't perfectly straight on graph paper. So these lines are perfectly straight. So I can see that the x-coordinate of this point of intersection is 2, and the y-coordinate of the point of intersection is -9. Okay, let's see what they gave me here. Okay, so for this one, this is why I wanted to do this with you. You're going to have to remember either how to get the y by itself, so put it in, this is standard form, get it into slope-intercept form. So you want to get rid of a positive 5x by subtracting, and then you're going to divide by -10, or you can use the x and y intercepts. So if you remember for the x and y intercepts, we put a 0 in for y first, so this goes away. So we have 5x equals 20, right? This would go away if I put a 0 in for y. 5x equals 20 means x equals 4. If you need to write that while I'm talking, write it. 5x equals 20 and then solve it. And then to find the y-intercept, I put a 0 in here, so that goes away. I have -10y equals 20. So write that down if you need to. -10y equals 20. And then solve it. Gives me y equals -2. So there's my first line. My next line, I'm going to put a 0 in for y. 2x equals -16. That goes away. 2x equals -16. So x equals -8. And then put a 0 in for the x. So this goes away. And I have 4y equals -6. So y equals -4. Wait a minute, I just messed this up, didn't I? I said x equals -8. Sorry. Let me go back. I'm running out of time. If I put the 0 in here, I get x equals -8, so that should have been right here. And then y equals -4 is going to be right here. And then I can see the point of intersection of the two lines. The x-coordinate is -2. And the y-coordinate right at the point of intersection is -3. So that is solving systems of equations by graphing. Again, I'll tell you, for the bookwork, I can't remember if it's bookwork or workbook, I would highly recommend doing it on graph paper. And please remember that workbook pages throughout the week, you're not writing on the workbook page, you're doing it on a separate piece of paper. So I hope you guys remember how to graph and can get the systems of equations stuff done. All right.